So today we're going to talk about direct and inverse variation, all right? We're going to do that by looking at these problems here on the front first and then having a discussion about them. You're all right with that? Even if you're not, that's what we're going to do anyway, so it's okay, all right? So let's start here first. Number one, a square with side units x. Let me start again. A square with side length x units has a perimeter of y units. What's the equation that we're going to use to find this? Perimeter. Y equals 4x. How do we find perimeter? Add up all the sides, right? If it's a square, they're all the same length, right? So x plus x plus x plus x, so y equals 4x. So what happens if x is 3? What happens if x is 7.5? I know now you're mad at me because I told you to put your calculators away, right? Because today we're going to talk about how comfortable we are with numbers, and right now you're not. I can tell how, because you all tensed up when I asked you this and wouldn't let you use a calculator. So I want to ask you this question. Is multiplying something by 4 the same as multiplying it by 2 and then by 2 again? Yes? So do you know what 7.5 doubled is? 15. Then what's 15 doubled? 30. We did that super fast and nobody was tense, but when I said what's 7.5 times 4, you were tense. Interesting. But here's another way. Do you know what 7 times 4 is? 28. Do you know what half of 4 is? What's 28 and 2? Two different ways to do it without even using a calculator. What about 9.5 times 4? What? 38, yeah. You seemed a lot less tense about that one. Because maybe you used one of those ways to do it in your head? Yeah? Okay. So what about this one? Number 2. A rectangle with a length of x units and a width of y units has an area of 60 units. Oh, well, yeah, obviously, x times y equals 60. I love how you said that. Like it's super obvious, right? That's good. Except what if I wanted the equation y equals? First of all, is there anything wrong with this? No, it's an equation, right? But we typically have our equations y equals. So how would we solve for y here? Yep, we would divide both sides by x to get y equals 60 over x. Is one of these equations more correct than the other? No, it just kind of depends on what you're looking for, right? In this case, it looks like we're solving for y, so it seems that this would be a better equation to use, right? Because if I use this equation, I would put y in and then have to divide by it every time. Or put x in and have to divide by it every time, right? Well, here it's already divided by, isn't it? All right, 60 divided by 4. How did you do that? I'm just curious about, like, the way that you did it. So you didn't use multiplication at all? That's fair. You didn't use division at all either, though. Okay. You know what some people did last period? With the same logic as this, they said 60 divided by 2 and then divided by 2 again. Is that the same? Yeah? Okay, so 15. Then what? What about 60 divided by 8? Isn't it divided by 2, divided by 2, divided by 2? We already did to 15, right? So if I just divide that by 2, wouldn't that give me the right answer? Yeah. What about 60 divided by 12? When I asked last period, how did you get that so fast? He said, because I know how to use a clock. Oh my goodness, right? 60 seconds. There's 12 numbers on a clock. So how much minutes in each section? 5. That's not even almost doing math. That's, like you said, being comfortable with a clock, right? Well, that's good. Isn't that actually doing math? Oh my gosh, shocking. You okay? Could I have done 60 divided by 3 and then by 4? Right? Because 12 is 3 times 4, isn't it? Okay. So just like multiple ways to think about these problems so that you don't seize up every time I ask you to do something like this. Okay? Guys, we're preparing for the TSI, right? That's coming up soon. Do you know how many problems on the test you can use a calculator on? You can't take a calculator in with you. Every once in a while, a 4-function calculator will pop up on the screen, but it's never guaranteed. So I'm trying to make sure that you are mentally prepared to do math problems, arithmetic problems like this. Yes? Okay. A man 5 feet tall casts a 3 feet shadow. At the same time of day, a tree Y feet high casts an X feet shadow. What's true about these two shapes right here? They are triangles. And what type of triangles are they? They are right triangles, and so therefore they are not equal. What's the geometry word that means kind of like equal but not? Starts with an S. And the word is not isosceles. I'll tell you that right now. Yeah. Close. Yes. Similar. If they're similar triangles, because it's at the same time of day, right? So they can be set up as similar triangles. We want to set up a proportion, right? Want to set up a proportion? They're similar triangles, so we can use proportions to solve, right? So, how about y over x? Equals what? 5 over 3. But what if I wanted my equation y equals? So you want to multiply both sides by x? So 5 over 3x. So what if x is 4.5? Everyone just panics because we have fractions and decimals now in the same problem. Well, guys, what's 4.5 as a fraction? Excuse me, as a decimal. No, I said it right the first time. You're confusing me. What is 4.5 as a fraction? So 4.5 or 9 halves, right? Well, what's 5 over 3 times 9 over 2? It will be 45 over 6. Does that simplify? They're both divisible by 3. You could tell that because both of these will simplify by 3, right? That would give me 5 over 3, or 5 times 3 over 2. What's 15 over 2? Yes? So you have to have patience with yourself to convert all these things to make sense. Yeah? So what if x is 9? Five over 3 times 9 over 1. So we could either multiply straight across and get 45 over 3, or we could simplify first and get 15 over 1. Five over 3 times 21 over 2. So again, we probably simplifying first is better, right? This simplifies to 7. So 35 over 2. Yes? Was this tougher than these up here? So you only want me to give you easy problems to get ready for the TSI? No, we got to do harder ones too, right? Okay, any questions about this? All right, what about this one? This problem is super weird to me. A person, 60 inches tall, looks through a mirror that they put on the floor to see how far up the wall they can see. Yeah, just look at the wall, right? But we need a math problem, so this is what we did. Got it? See, to me this looks like similar triangles again, doesn't it? Does it look like that to you? Guys, how many ways could we have actually set up this proportion? 4 different ways. Why did I have us set it up like this? Where did I specifically put the y? In the numerator? At the beginning. Because if I'm going to try to solve for y, I want the y in the numerator, and I want it on the left-hand side because that's just how we've always been taught, right? It doesn't have to be on the left-hand side, but we really for sure want it in the numerator, don't we? Think about that when you're setting this one up. Is this picture labeled all the way like it should be? What's missing? The 60, and that goes on the person. So set up a proportion for me. Y over what? 30 equals? Are you sure those are all in the right place? If we're starting with y, that's the short side. So we decided to say short side over long side of the same triangle. Could I have said short side over short side? Yeah, a lot of different ways to set up a proportion in there. Now, what if I want this to say y equals? What would it be then? I'd have to multiply both sides by 30, right? What's 6 times 3? 18. And I have two more zeros, 2 more tens places. Yes? So what if x is 20? I may not know 1800 divided by 20, but what's 18 divided by 2? 9. So this should be 90. What about if x is 40? That one's a little trickier, isn't it? Close. It's just 45. Okay. And then what if x is 60? 30. Good. Okay, so far? Remember, we're just getting data right now, aren't we? Okay, doing some problems, getting our feet wet, getting back to in the use of doing these kind of problems, but we're also kind of gathering data, okay? For X people to travel, the cost Y in dollars for renting a bus at $7.50 per person. So what does my equation look like? 7.5x. Very good. What if x is 10? 75. What if x is 25? Okay, how do you know that? $187.50. What if x is 30? Guys, what's 7 times 30? 210. What's half of 30? So it's 210 plus 15. 225. Are you getting an idea of how to break these things up sometimes? Yeah? Okay. We could have done that one here, right? Okay. Just something to think about. All right, what about this last one? The bus will cost $180 to rent. If X people ride, how much will it cost per person? The cost, How many people ride plus or times the cost per person should equal 180. So y should equal 180 over x. Very good. So what if x is 8? Should we try the 2's? Okay, so what's 180 divided by 2? 90. What's 90 divided by 2? What's 45 divided by 2? 2250, right? 22.5. What about 180 divided by 12? Goes into here once, and there's 3 left over. Excuse me, 6 left over. So 15. And what if x is 30? What's 18 divided by 3? 6, so 6. Yeah? Questions? All right. Let's look at the back. For just a second, I want you to keep looking at the front. Okay? I'll let you turn it back over and write in just a second, but for a second, you guys still look at the front. Okay? So first, I want to look at just problems 1, 3, and 5. You okay with that? Just problems 1, 3, and 5. So the left-hand column problems, yeah? Look at the tables of those problems. As x blanks, then y blanks. As x increases, then y increases. Do you agree with that? Look at the relationship. X and y have a constant, kind of. Does this look familiar to you at all? This form? Y equals mx, right? You've done this kind of relationship since right before Algebra 1, probably in 7th grade. 8th grade for sure. Okay. What's another, what did we always call that m? Slope. And what's another word for slope? It's called a ratio or a rate, right? Look at the equation. What's the equation look like? TJ, I think, said it just a second ago. Y equals mx, right? But for we're now in Algebra 2, so for some reason we have to use a different letter. So we're going to say y equals kx. Okay. What's this called? Direct variation. Yeah? Go ahead and turn your paper over and copy that down for me, please, before we go on to the problem. Got it? So look at the problem with me real quick. If y varies, how is it varying? So if y varies directly as x, and y is 12 when x is 8, then what is y when x is 24? So it actually tells us some information right here. If I already know x and y, what am I going to do first? I'm going to solve for, so the first thing I have to do is solve for k, using what it tells me at the beginning. So y equals kx is what I start with. I know y is 12. I know x is 8. How do I solve for k? Good. Divide by 8. What is 12 divided by 8? So 1.5. Are you okay with that? Could we leave it 3/2 if we wanted to? Yes. Well, now that I've solved for k, what am I actually trying to solve for? So after I solve for k, I want to solve for y. So I have to start over. Y equals kx. But this time, what do I know? I know k. So y equals 1.5. And what else do I know? X is 24. Do you know 1.5 times 24 off the top of your head? Do you know what's 1 times 24? And what's half of 24? So what's 24 and 12? 36. That answers the question, doesn't it? Questions? Let's look at the other column. Go ahead and turn yours back over. Look at the front page. What do problems 2, 4, and 6 have in common? If x blanks, then y blanks. Somebody else than answered last time. If x increases, then y is decreasing, right? If x increases, y decreases. X and y have a constant. It's easiest to see in these two problems because of how we wrote our answer. X and y have a constant what? Well, what are they doing to each other? Multiplying? What's another word to say multiplying? They have a constant product. This is a division. This is multiplication. Yeah? What do the equations look like? Well, first they look like this, right? That's where we started. And then we always went to this. Y equals what? K over x, right? Because we'd have to divide both sides by k. So which one of these is right? Oh, both of them? So could I put or? Okay. Because they're the same, right? Just solve for a different variable. Go ahead and flip it over and copy these down. See if you can figure out the name at the same time. Inside of your head. We'll talk about it in just a second, but write this down first. Tell me what's the most common incorrect answer for the name. Well, no, because that's already this one. What's the most common incorrect answer? Indirect, right? Because if this is direct, this should be indirect. Except you know from the title of the worksheet that it's called, inverse. Inverse variation. The way that things change. It's either a direct change or an inverse change. If y varies, what's it going to say? Inversely as x. And y is 12 and x is 8. What is y when x is 24? So first of all, we have to do what? Oh, in both of them, we have to do the same thing. Solve for k. Oh, look at this one. This equation already has k solved for. That's so nice. xy equals k. Well, x is 8, y is 12. What's 10 times 8? What's 2 times 8? What's 80 and 16? 96. Look how much math we're doing without our calculator. Now that I know k, what do I want to do? Solve for y. So I have to start again, xy equals k, but this time I know k. Oh man, do I even want to use this? In fact, I don't want to, right? Because what do I know? I have an equation that's y equals, so I don't want to use this one this time. I can, just adds another step. What I want to use this time is y equals k over x, because I know k is 96. Y equals 96 over x. And x is 24. So y equals 96 over 24. So y equals 96 is super close to 100. 24 is super close to 25. How many times does 25 go into 100? Well, does it make sense that 24 would go into 96? Because that's 4 less. And this is 1 less than 25. That's my answer. Any questions so far? Okay, can I try to trick you real fast? If I multiply two numbers together and get k, is that always inverse variation? Yes. If I have a common ratio, is that always direct variation? If my table has an increasing x and an increasing y, is that always direct variation? No. If my x increases and my y decreases, is that always inverse variation? Look at problem number 1. These are your homework problems, by the way. Okay? What's happening to x? What's happening to y? Increasing, decreasing. So I think maybe it is inverse variation, but I know if it's inverse variation, x and y have to have a common product or a constant product. What is 4 times 110? 440. What is 5 times 88? 440. What is 8 times 55? 440. So do I know that this is inverse variation? Yes. So if I'm trying to decide whether it's direct, inverse, or neither, because it can be, right? This would definitely be inverse. Do you understand how to do those? And then these are just like the ones that I showed you down here at the bottom. Got it? Any questions?